You can graph whether it's in standard form or whether it's in vertex form. I've chosen one of each. You'll notice that there are several things on here. I do want them listed out, so I don't just want them on the graph. All right, so part of this question says, find the axis of symmetry, vertex, and y-intercept, then sketch the graph. So I actually need those listed out. If it is in standard form, then the axis of symmetry is going to be negative b over 2a. In this case, it's going to be negative, my b is negative 8, over 2 times my a, which is negative 2. So I have a positive 8 over a negative 4. My axis for this one is going to be x equals negative 2. And I do need to put that on the graph. So I do need to go to negative 2 on the graph and put that vertex, but I also need to lift our axis, but I also need to list it out. All right. The next thing it says is to find the vertex. The vertex, I've already found the x value of it. That is my negative b over 2a. My y value is what happens when I plug that into the function. All right. So in this case, I'm going to plug in a negative 2 to my original function. So negative 2 times, instead of x squared, I'm going to say negative 2 squared minus 8 times negative 2 minus 10. Negative 2 squared is 4. 4 times negative 2 is negative 8. Plus 16 is positive 8. Minus 10 is negative 2. So my y value here is also negative 2. So my vertex is going to be the x value and the y value. And so I'm going to go to the point negative 2, and put my point there. The third thing I need to find here is my y-intercept. When it is in standard form, the y-intercept is always 0 and c. So in this case, it is 0, negative 10. So now I'm going to go to the point 0, negative 10 and plot that. That is 2 away from my axis of symmetry, so I can go 2 away on the other side and plot a corresponding point, and then that will help me graph my quadratic, which looks like this. All right? So I should have 3 answers listed out. I should have my axis of symmetry, my vertex, my y-intercept, and then I should sketch the graph. All right? So with standard form, we had our A, our B, and our C. For vertex form, you still have an A, but now you have an H and a K. All right? Now remember, this is X minus H plus K. So when you use your H, you're going to do the opposite of this that's in here, okay? Because the formula already accounts for a minus. So again, I need to find my axis. But my axis is just X equals H. If you need to think of it as negative H, you can, but it's the opposite of what's in there. So in this case, my axis happens at X equals positive 1. Positive 1. All right. And so I'm going to go to positive 1, and I am going to sketch my axis of symmetry. My vertex, for vertex form, my vertex happens at H, K. So in this case, my H is 1, my K is 2. So I'm going to the point 1, 2, and plot my vertex. The only one you actually need to calculate is your y-intercept. Your y-intercept is always going to be 0, and then what happens when you plug 0 in? And so I have to actually calculate this. 2 times 0 minus 1 squared plus 2. 0 minus 1 is negative 1. Negative 1 squared is positive 1. Positive 1 times 2 is 2. 2 plus 2 is 4. So I get a vertex of 0, 4 here. I'm going to go to 0, 4. Plot that, mirror it across. And then once again, I can sketch my parabola. So you will still have 3 answers for this plus the graph. I have my axis, my vertex, my y-intercept, and then I have sketched my graph. So I am looking for those listed out on the side there. I have to have them listed and labeled. So I need to see that this is the axis. I need to see that this is the vertex. I need to see that that's the y-intercept. And then sketch them on the graph. The only difference between this and the first page is that it is an inequality, not an equation. Okay? So if it's in standard form, you're going to do it exactly the same way. If it is in vertex form, you're going to do it exactly the same way. So I still am asking you to list these things out. My axis here is going to be -6 over 2 times -3. So that's going to be -6 over -6. That's going to be an axis of +1. So I'm going to go to +1 and I'm going to graph that. All right. And then my vertex is going to be +1, and then I've got to plug it in. -3 times 1 squared plus 6 times 1 minus 6. So I get -3 plus 6 minus 6. I get a vertex of a y value of -3 there. All right. So I'm going to go to 1, -3, and I'm going to graph that. And then my y-intercept is just going to be 0, -6. So I'm going to go to -6. And mirror that across. This is going to be pointing down, which it should be because it's a -3 in front. This tells me it's pointing down. At this point, it changes how I graph. I have to look at my inequality before I graph this to decide if it's going to be solid or dashed. In this case, it does not have an or equal to, so I'm going to dash this, meaning I am going to connect those with a dashed line, not a solid line. All right, y is less than that. So typically I just go to my vertex. Which side of this would make it less than the vertex? Well, inside is less than the vertex, right? On the outside, I'm greater than that line. I can also go to my y-axis here, my y-intercept. Which side is less than that y-intercept? Well, it goes down in here, so it's inside the graph. So when I shade this, I'm going to shade inside that parabola. Less than is not always inside. Greater than is not always outside. It depends on which way it's facing, right? Then you're going to have to decide if it's facing up and it's greater than, that would be inside. If it's facing down and it's less than, that would be inside. So you just have to pay attention. Find the length and width of a rectangle whose length is 7 centimeters longer than its width and whose area is 60 centimeters squared. So typically on these, it's a great idea to actually draw the rectangle so you can get an idea. This is saying that the length is 7 centimeters longer than the width. So if this is my width, then my length is going to be x plus 7. To find the area of a rectangle, you just multiply those. So x times x plus 7 will give us the area. And then I'm just going to solve this. Distribute. I have x squared plus 7x equals 60. For a quadratic, you want to set it equal to 0. So move this over. X squared plus 7x minus 60 equals 0. So now I'm looking for factors of 60 that subtract to give me 7. What are factors of 60 that subtract to give me 7? So in this case, it's going to be a positive 12 and a negative 5 to give me that positive 7. And so then I set each factor equal to 0. And I solve for what my x is. X can either be negative 12 or x can be 5. We're talking about length. We automatically know it cannot be negative 12. So the only option is that this is going to equal 5, which means this will equal 12. Which if it's a leading coefficient of 1, that's usually how it's going to work out. Those two factors are going to be your dimensions there. So 5 centimeters by 12 centimeters are my dimensions. You'll notice I just say divide. I don't say divide using long division or divide using synthetic. You may do either, all right? So if you do long division, you're going to set it up just like you would have in elementary school. You do still need to make sure that if it starts at 4, that I have a space for every exponent from that down. So I do have into the 4th there. I have n to the third. I have n squared. I have an n, and I have a constant. So just like in synthetic, I do have to account for all of them. And then your n minus 6 goes on the outside. All right? If you're doing long division, you're just going to say, how many times do I multiply n to get 6n to the fourth? I would multiply that 6n cubed. And then you just distribute 6n cubed times n, 6n cubed times negative 6. And then remember, you are subtracting. So that is adding the opposite here. Those cancel. Then I have negative 42 and positive 36. That's going to give me a negative 6n cubed. Bring down your 38n squared and do the whole process again. I multiply my n by a negative 6n squared to get that. Distribute it through. And then again, you are subtracting, so you are adding the opposite. Then 38 negative 36, give me a 2. Bring down the negative 3. And do it again. N times what equals 2n squared, a positive 2n. So that's going to give me 2n squared minus 12n, adding the opposite. And then cancel. We get a negative 9. Positive 9, sorry. Bring down the negative 55. And then what am I multiplying by? I'm multiplying by 9. 9n, negative 54. Again, adding the opposite. Cancel, and you get a negative 1 as your remainder. Remember, your remainder goes over your divisor. So that's my answer, long division. If you want to do synthetic, you're going to do the same thing, but you're just going to use your coefficients. 6, negative 42, positive 38, negative 3, and negative 55. Now remember, for this one, I do the opposite, what makes it 0. So I'm not going to put a negative 6 out there. I'm going to put a positive 6 out there. Okay? And then I'm going to add down, multiply up. 6 plus 0 is 6. 6 times 6 is 36. Negative 42 and positive 36 are negative 6. 6 times negative 6 is negative 36. 38 and negative 36 are 2. 6 times 2 is 12. Negative 3 and 12 are 9. 6 times 9 is 54. Negative 1. To finish out synthetic, I have to put my x's back in. I started with x to the fourth, so I'm going to put in 1 lower than that. So it's going to be 6x cubed minus 6x squared plus 2x plus 9 minus, this is my remainder, 1 over my original, what I was dividing by, in minus 6. Same answers. 2 different methods. You can use either one. Synthetic substitution means use synthetic division, but I only want the remainder, okay? Basically, it's saying use synthetic division to tell me what would happen if you plugged in a 5. When it is synthetic substitution and they give it to you like this, you don't change the sign. So I'm going to do the same process. I'm going to use my coefficients, negative 3. I'm going to make sure that I have a cubed, squared, 1, and a constant. If I do not have one of those, I need to put in a 0. I'm not going to change the sign of that 5, and I'm going to do synthetic division here. So I am just going to add down, multiply up. Negative 3, 5 and negative 3 is negative 15. 12 and negative 15 is negative 3. 5 and negative 3 is negative 15. 18 and 15 are positive 3. 5 and 3 are positive 15. 15 and negative 6 are positive 9. All right? My answer here is only this guy right here. That is my answer. If you give me the entire with x's in there, you're going to miss this question. All right? Because that's not what it is. 9 is what happens if I were to plug in a 5 here. And this is the way you can check it. You do not have to do this step right here, but you are certainly welcome to check it But that's how you check it. If you plugged it in, you would get 9. 9 is the answer here. Nothing else for synthetic substitution. All right, so when it asks this first question here, state the possible rational zeros, then factor. You are going to use the little shortcut of my constant and my leading coefficient. So I need to first list out all of my values of that ending number, 5. Everything that multiplies to give you 5. Well, that is easy. That's just 1 and 5. And then I need to list all the values of the leading coefficient, which happens to be the same number, so hopefully this is not a confusing one to look at. Leading coefficient here. Oh, well, that's 1 and that's 5. And so then my possible rationals come from that. So you should have possible rational zeros listed. And you're going to list all the possibilities. You're going to say 1 over both of these. 1 over 1. Well, that's just 1. And remember, you have to consider the positive and the negative. 1 over 5. Well, that's 1/5. And you have to consider the positive and the negative. Then you're going to say 5 over 1. That's just 5. Again, your positive and negative. And then 5 over 5, which is just 1. And I've already listed that one. So I do not need to list that again. All right. If it reduces to 1 that I already have, we don't have to list it again. So this is actually the first answer to this problem here. Possible rational zeros. There it is. That's the answer to that one. The second thing tells you to factor, and they gave you a factor to start with. All right. So the first thing I would probably do is say factors and list the one they gave me, because I will count off if you don't list the one they gave you, because all your factors should be able to FOIL to the original. And if you don't list that guy, he won't. Okay. Well, how do I use him to get the rest of my factors? I'm going to divide. All right. Because if I divide by that factor, I will have another factor of that number, and then I can factor him. It's almost like using a factor tree. All right. So over here, I'm going to do synthetic division with the factor that they gave me. Remember, when it gives it to me in a group, I change the sign. So I'm going to use positive 5. 5x cubed, negative 31x squared, positive 31x, and negative 5. Again, if you are missing an exponent, put a 0 in for it, okay? If it had jumped from 3 to 1, you should put a 0 for x squared, okay? So just make sure that's there. And then I am going to do division. Add down my 5. Multiply up. 5 and 5 are 25. Add down, that's negative 6. Multiply up, negative 30. Add down 1, multiply up, negative 5. It's positive 5 and 0. By the way, how did I know I had made a mistake?
Because you got a 0.
Because I didn't get a 0. I immediately knew something was wrong because they gave me a factor. If they gave me a factor, my remainder is always 0, okay? So once you have this, you have 5x squared minus 6x plus 1. I need to see if I can factor it, okay? If you do not see the factoring right away, so I right away can figure out what that factoring is without doing my long method, all right? But if you can't, so if you can't say, oh, that's 5 and 1, that's going to be a positive and negative 1. The negative 1 needs to go with the 5. The positive 1 needs to go with 1. Like if you can't see the foiling, do your long method. So just multiply the 5 to the 1. That's a 5. Factors of 5 that add to 6. Technically, it's going to be a negative 5 and a negative 1 because I need a negative 6. So I have 5. Remember, I rewrite it. 5x squared minus a 5x minus a 1x plus 1. And then I can factor by grouping. Remember, when I group behind a negative, change the sign. On the first, I can pull out a 5x, and I'm left with x minus 1. On the second, I can't pull anything out, so I'm going to put a 1, and I'm left with x minus 1. And so my factors are going to be x minus 1 and 5x minus 1. All right? So then I'm going to go back over here and list those as my additional factors. X minus 1, 5x minus 1. And that is the second answer to this question here. Factors completely. Factor the polynomial. This next section is just factor completely. By the way, if there is no equal sign, I am not asking you to give me what x is. Okay, so there's the next section does actually tell you to give the zeros, which means set each factor equal to 0 and solve. This doesn't want you to solve, this just wants you to factor, okay? And I don't think I pulled one, but you will need to know your factoring of cubes, which I think is on one of these. But if it's not, you do need to know your cube factoring, which I can give you some of those as well. For something like this is a special case. X to the fourth minus 81 are both perfect squares. So the square root of x to the fourth is x squared. The square root of 81 is 9. And so I can do this. When I have a larger exponent, I am looking for special cases to continue factoring, which I have one. X plus 9 is as small as it can be. But x squared minus 9 is not. That is another perfect square. So I can actually keep factoring that to x plus 3, x minus 3. So my factoring would look like this. That is completely factored. All right? It will not always do that, though. Look at the next one. I am looking for factors of negative 35 that subtract to give me 2. Well, that's 7 and 5. Negative 7, positive 5. So I'm going to say m squared plus 5, m squared minus 7. Neither of those is a special case. Neither of those can continue factoring. So for that one, I am actually done. You do also need to know how to factor your perfect cubes. A cubed plus b cubed. You do need to know how to do this one. Now, if they just list a normal number, so if you look on this sheet, like number 40 just has a 3. 3 is just going to be x minus 3, period. It doesn't have a partner. So integers are not going to pair up with anything. 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, those are what they are, okay? But if they have a root or an I, they will always have the opposite with them. Now remember, we're saying, what would this guy make equal to 0? Well, x minus the square root of 3 would make that 0. If it's a square root of 3, I also have to say, well, x plus square root of 3. All right? That's my other 0. So the other 0 I'm looking for is negative square root of 3. If I have x minus, or x, a negative 3i, that's x plus 3i. And if I have a negative 3i, I also have a positive 3i. So it's going to look like this. So anytime you have an I or a radical, you have to partner it with the opposite, okay? That is also an additional 0. If you just have 1, 2, 3, 4, 5, those do not generate additional zeros. When you are foiling these, foil your conjugates first. It will make your life easier. So I'm going to foil this one first. But remember, this is a special case. If I have A plus B and A minus B, it will always be the first one squared minus the second one squared. So you really don't have to foil them out when they're conjugates. The first one squared is just x squared minus the second one squared. When I square a square root, I just get what is inside. That's the foiling of that one. The second one's also a conjugate. Square the first one minus square the second one. 3 squared is 9, and then I have I squared. I do need to simplify this one before I foil the next group. All right, so this x squared minus 3 stays that way. But I squared is negative 1. So I have negative 9 times negative 1. So this guy is going to be x squared plus 9. That will always happen with these, all right? It will always happen that way. And now I have two pretty simple binomials that I need to FOIL to finish this off. And so to finish this process here, I'm going to FOIL. X squared times x squared is x to the 4th. X squared times 9 is 9x squared. Negative 3 times x squared is negative 3x squared. And negative 3 times 9 is negative 27. I do need to combine my like terms. So x to the 4th doesn't have a like term. Positive 9 and negative 3 give me positive 6x squared. Negative 27 does not have a like term. This is my answer right there. This says state the number of complex roots for each equation, then factor and find all roots. All right, state the number. This is a very simple question. The number of complex roots. That will always be the degree of your polynomial. What's the degree here? Well, it is 4. So that is an answer everybody should get on this test, right? The number of complex roots is just your degree. So that answers the first question. Factor and find the roots. Well, factoring's not hard. I need factors of 16 that subtract to give me 6. Well, that's going to be x squared minus 8, x squared plus 2, right? Negative 8 and positive 2. In this case, it actually wants me to find them, find the roots. So I'm not just factoring like I was on that other problem where I just listed all the factors. I need to set each factor equal to 0 and I need to solve it, all right? So I'm going to say x squared minus 8 equals 0, x squared plus 2 equals 0. And then solve, add my 8, x squared equals 8. Take the square root of both sides. X equals the positive and negative root of 8. Check to see if I can simplify it. If it were 9, the square root of 9 is 3, positive or negative 3. If it's 8, I need to do my factor tree and see if I can take anything out, which I can. So this is 2 and 4, 2 and 2. If it pairs up, it comes out. If it doesn't, it stays in. So one of my roots, or two of them rather, are going to be positive and negative 2 square root of 2. That counts as 2 roots. You can list it out, positive 2 square root of 2, negative 2 square root of 2, which I think is what your answer key does, or you can put the plus minus in front of it. I know what you mean by that. Then I'm going to solve the other one. For this one, subtract my 2 over, x squared equals negative 2. Take the square root of both sides. X equals positive or negative square root of negative 2. First of all, 2 is prime, so I cannot factor tree that one, but the negative comes out with an I. So I have I square root of 2. Those are my other 2 roots. So I also have positive or negative I square root of 2. When you have told me, hey, there are 4 roots, then this should be 4 answers. 1, 2, 3, 4. You just told me there were 4, then you should find 4. If you don't find 4, you're missing something, right? Okay, so make sure that those match up because I'm asking for all real and imaginary roots here. So that should be every single possible root. Square roots, imaginary roots, integer roots should add up to 4. All right, describe the end behavior. All right, the first thing I'm going to look at is my degree. Degree. If my degree is even, they go the same direction. If it is odd, they go opposite directions on the end. I'm talking about what happens on the end of my function, not in the middle, on the end, okay? Once I figure out if they go the same or opposite direction, I look at my leading coefficient. If that is positive, then it goes up. If it is negative, it goes down. All right? So you can think of it as like a little chart. All right. We have even and odd. And then we have positive and negative. All right. So if it is even and positive, they go the same direction on the end. Even and negative, they go different directions on the end. Both down, both up. If it is odd and positive, they go different directions, but it is continually up. So down on the left, up on the right. If it is odd and negative, it goes continually down. Something like that. You may give me the answer rises on the left, rises on the right, up on the left, up on the right. For this one, it is even, same direction. It is positive, both up. So you can even say up on the left, up on the right. I'll take that, okay? But you have to tell me on the left side what happens, on the right side what happens, all right? You have to tell me how it goes. In this case, it goes up on the left, up on the right, all right?